Assalamualaikum and hi to Dr. Basida binti Hamzah and our fellow friends. So today we will talk about practical implementation of OS concept system scheduling. For this system, we choose first come first serve.
Hi, Assalamualaikum warahmatullahi wabarakatuh. Before we dive into the topic, let me introduce our team members. We have Muhammad Hadi Irfan here, which is me. Next is Zulhadi Zakwan and Muhammad Iskandar. Now, let's move on to understanding the concept of first come first serve scheduling. First come, first serve is one of the simplest CPU scheduling algorithms. It follows a non-primitive queue-based approach, meaning processes are executed in the exact order they arrive in the ready queue. It operates on a first in, first out principle, ensuring fairness. However, first come, first serve does not consider process priority or burst time. This can lead to inefficiencies such as the convoy effect, where shorter processes are stuck waiting behind longer ones. This increases both the average waiting time and turnaround time. Despite its simplicity and minimal overhead, first come first serve has poor response times, making it unsuitable for interactive or real-time systems that require quick task execution. Let's break it down into the four key components: turnaround time, waiting time, Gantt chart, and average calculations. First, we have turnaround time. This represents the total time taken by a process from the moment it arrives until it completes executions. It is calculated as turnaround time equals to completion time minus arrival time. This helps us measure how long a process takes to finish. Next, we have a waiting time, which is tell us how long a process spends waiting in the ready queue before execution begins. The formula for this is a waiting time equals to turnaround time minus burst time. A higher waiting time indicates inefficiency, which is a drawback of first come first serve when dealing with a shorter process stuck behind a longer ones. The Gantt chart visually represents the sequence of process execution. It shows how each process is scheduled in the exact order of arrival and ensures there are no interruptions. This provides a clear timeline of execution and completion. Finally, we calculate two average, which is the average waiting time and the average turnaround time. These are found by adding up the waiting and turnaround times for all processes and dividing by the total number of processes. Now, let's go through the code flow for the first come first serve scheduling algorithm. This flowchart visually represents the step-by-step process of handling and scheduling process in first come first serve. The process begins by reading the input values. This includes the numbers of process and each process arrival time and burst time. Then we initialize the key variables, including a loop counter. Next, we check if we have read all the process. If not, we continue reading arrival and burst time. Once all processes are read, we sort them by arrival time to ensure they are executed in the correct order. We now initialize the key values. Current time, total turnaround time, and total waiting time is equal to 0. This helps us to keep track of process execution and calculate waiting and turnaround time efficiently. Before we executing a process, we check if the current time is less than the arrival time. If yes, we set the current time to arrival time to ensure the process starts when it arrives. If no, we proceed to the calculate completion time, turnaround time, and waiting time. After each process executions, we update the current time and calculate turnaround and waiting times. Then we display the process table showing the calculated value for each process. Once all processes have been executed, we calculate the average turnaround time and average waiting time. These values helps analyze the efficiency of the first come first serve algorithm. Finally, we use the Gantt chart to visualize how each process was scheduled over time. The Gantt chart is drawn, displayed, and the program ends.
Hi, my name is Muhammad Zal Zakwan. So today I will show you how the code is run. So first, for the first come first serve uh, scheduling. So this is the code. At here we have a user input, and then this is the output. And last but not least, I will show you how the program work is already run. So I will put 4, and for arrival time process is 0, and then 4, 1, 6 for the third, 3, and last. So this is it. That's all from me. Thank you. So, as you can see, this is our detail about coding Java. Result, we have 4 process with different arrival and burst time. And as you can see, we calculate the average turnaround time and average waiting time.
From the observation, we can conclude that first come first serve is a simple and fast scheduling algorithm that processes tasks in the order they arrive. However, it suffers from the conveyor effect, where long process delay shorter ones, leading to poor CPU utilization and high waiting times. FCFS lack prioritization, making it unsuitable for time-sensitive tasks but useful in systems like printing and batch processing. The project faced challenges such as logic error in coding and scheduling conflicts, which were resolved through careful planning and debugging. Thank you for watching this video. I hope this explanation helps you understand more better.